Hello. So in this short clip, I'm just going to be discussing this section of the slide number 15 from the Computer Networks course. So the section that I want to discuss is the additive increase, multiplicative decrease. Okay, so what is this additive increase, multiplicative decrease? It's short form AIMD. It's basically a control law used for bandwidth allocation. So let's see what this means and let's understand what this sawtooth that they're talking about really is talking about. So let's just recall that if we want to allocate capacity to senders as in like hosts that you have on a machine, if you want to allocate the capacity to these hosts, then the network layer is the one that's going to be responsible for providing feedback, i.e., the network layer that consists of the IP protocol, Internet Protocol, and that's it's responsible for routing and this kind of stuff. This is the one that's going to provide feedback, basically telling us that there's a lot of packets being sent right now, and it's hard for me to handle all these packets. Because as we know, routers do have a capacity. They have buffers, as mentioned here, and these buffers have a capacity. They're not just unlimited. So once we start reaching this capacity, the network layer is going to want to tell us that, hey, you're kind of pushing it here with the amount of packets that you're sending. Okay, and then how do we actually adjust the amount of packets that are being sent? Well, we're just going to use the transport layer for that. And in this case, we're going to be discussing the TCP protocol and how the TCP can actually be used to limit or decrease the amount of load that's being sent to a network in the case that there is a congestion. Okay? And basically, a good allocation, a good bandwidth allocation should be efficient and fair. Efficient and fair meaning that if I have three hosts on the network, they're all trying to send their own traffic. So my goal as a network person should be to make sure that all three of these hosts are it's fair between them, so all of them have the ability to send on the network and like a relatively equally between them, and that the network is being used efficiently. The bandwidth is being used efficiently. So how do we perform this good allocation? Well, this is what the AIMD protocol is used for. So here it's just discussing some bandwidth allocation models. I'm going to skip this slide for now. I'll get back to this in a bit. So like mentioned before, the network layer returns feedback on current allocation to senders. So the network layer is responsible for telling us that the amount of traffic being sent on the network now is too much. There's congestion happening. The network layer tells the hosts that there's congestion. And then the hosts are responsible using the transport layer of adjusting the behavior, of adjusting the amount of load that's being sent on the network. Okay, so this is what AIMD is actually used for. AIMD is a control law host that that can be used to reach a good allocation. Please ignore this line because there seems to be some grammatical mistakes here. So hosts additively increase the rate, i.e. the window size, while the network is not congested. Okay, so what does this actually mean? Well, what this means is that the host has no idea what's going on on all the other network in terms of the transport layer, in terms of the TCP protocol, has no idea what's going on inside of the rest of the network. So all the host really does is it's going to keep increasing the amount of load that it's being sent on the network, as long as there's no feedback telling it that the network is congested. So the host is going to keep on increasing the load, just it's just waiting to get any feedback from the network layer to tell it that there's a congestion happening. Okay, so hosts, what happens after that? What happens after that is that if when the host keeps additively increasing, the rate at which it's sending packets, well, there's going to come a point where congestion starts to happen. When that point comes, that's when the network layer is going to tell the host that there's congestion happening, and the host is going to start to quickly, multiplicatively, meaning quickly, decrease the rate by which it's sending packets. So in terms of what that actually looks like, it looks like this. So here we have hosts 1 and 2, and both of them share a bottleneck. So as you can see, hosts 1 and 2 both go to the same router, and the amount of power that this link has is 1. The amount of bandwidth, sorry, that this link and this link has is 1. And the amount of bandwidth that this link has is 1. Okay. So as you can imagine, if host 1 is sending like full bandwidth down this link, like the full capacity of this link, and host 2 is sending the full capacity of this link, then once they reach this point, well, there's going to be a problem because this link only has 1. And this host is trying to send a capacity of 1, which is the maximum. This host is trying to send a capacity of 1, which is maximum. And now they're gonna all get congested inside of this router because there's not enough space for the router to send all these packets at once. So this is why we need the AIMD. So both hosts are going to start off at 0, and then step by step, a little by little, they're going to increase the amount of load that they're sending. So maybe we're going to start off at 0, and then 0.1, 0.2, and this one 0, 0.1, 0.2, 0.3, until both of them are sending, and they're waiting to get any feedback telling them that there is congestion. So what happens? What happens is that once the router starts to see that there is congestion, it's going to tell both hosts, hey, there's congestion happening. So the hosts are both of them going to decrease the amount of load that they're going to send. Okay? They're going to decrease and decrease. And then they're going to start increasing again, step by step, step by step, step by step. And then once there's congestion again, the router is going to tell them, and they're going to decrease. So as you can see, there's like a cycle of increase and then decrease, increase and then decrease, increase and then decrease. So this is what it's saying here. In this case, we started off with host 1 using up a lot of bandwidth. Host 1 is using like, let's say 0.7, and host 2 is only using like 0.2. So what's going to happen? Host 1 and 2 are both going to increase, increase, increase. So host 1 is going to go up like this. Host 2 is going to go up like this. So the arrow is going to go up like this. And then we're going to start to get into this congested zone. This gray means it's getting congested. So then the router is going to tell both hosts, hey, you need to decrease. So they're both going to decrease. And they're going to start to increase again. And then the router is going to send them, and they're both going to decrease. And they're going to increase again, and then decrease, and then increase, and then decrease, until they reach this point. And this point is the exact point that we want to reach, because this point means that host 1 has exactly 0.5 bandwidth, and host 2 has exactly 0.5. So we've reached a very fair and efficient point, which is exactly what the goal is. Again, the same sawtooth pattern that we saw here, it's just being showed in a different way here. So increase, increase, increase. The router says that there's congestion, decrease. Increase, increase, increase. Router says that there's congestion, decrease, and so on. So what it's saying is that the AIMD protocol, even though it's very, very simple, but it always converges into allocation that is good, meaning that is efficient and fair. Okay, now here it's talking about feedback signals. I'm not going to get into that now. I hope you understood the general idea of the AIMD, and I hope this was beneficial. Thanks a lot.